find the distance between the point P and the plane given by this equation. Suppose this is the plane, then we can always find a normal vector, let's say n, and a point on the plane Q. And from this P, the distance means perpendicular distance, let's say this. Unfortunately, we don't know this point. If this is the point, if we can find this point on the plane, then we could simply use the distance formula, but that's not the case. We can find a point on the plane. It could be anywhere, let's say this, and the normal vector is always normal to this plane, so like this. And to find this distance d from here to here, we take this vector qp and project onto this normal vector and find the magnitude of this projection, which is same as scalar projection, positive value. So here to here, that will be the scalar projection, and this height or this length will be same as this distance. Okay, so first we need to find a point on the plane and normal vector. So this equation, so normal vector, okay, normal vector b, just the coefficients of x, y, and z. So 3, -1, 1, 3, -1, 1 from the equation of the plane. Now a point, let's say q. Now we need to find x, y, z so that their linear combination is 4. So we can choose anything. We can take x0, y0, that gives z equals 4. So 0, 0, 4. So this is one of infinitely many points. Okay, now to find this projection of qp, we need qp vector. So subtract the coordinates of q from p, p minus q, and p is 2, -1, 5. So 2 minus 0, 2, -1 minus 0, -1, 5 minus 4 is 1. Okay, and to find this projection of qp, so the distance is just qp vector dot normal vector, and we're going to take positive over magnitude of n. So let's find magnitude of n. That's 3, -1, 1. That's the normal vector. I wrote v, but we can write n. Okay, so that is the square root of 3 squared plus -1 squared plus 1 squared, square of 11. And we need to find the dot product, qp dot n. So qp is here, n is here, so 2 times 3 is 6, plus -1 times -1, positive 1, plus 1 times 1 is 1. So this is 8. We are supposed to take absolute value, but this is already positive, so this is good. Thus the distance is dot product, absolute value of dot product on the top, divided by, that's the magnitude of normal vector, which is √11. This is it, answer. Or you can multiply top and bottom by √11, that gives us 8 √11 over 11 units final.